Okay. Hi everyone. This is our research survey about unobtrusive stress detection. So first of all, why is detecting stress important? Well, stress is associated with greater risk of diseases, including cardiovascular disease, hypertension, and infectious disease. And I should also point out that stress can also lead to mental illnesses like depression. So detecting stress is really important, especially for early stage detection, so that you can prevent major mental diseases to happen. Okay, so also talk about the current methods of stress detection. So the most traditional way of detecting stress is by psychological questionnaires. It's like you fill out these forms consisting of a lot of multiple choice questions regarding your eating patterns and sleeping patterns, for example. And also there's some new methods of detecting stress that requires wearables or sensors or laboratory environments. For example, they will need you to put on a special watch, for example, and then the watch will monitor your heartbeats, and then they will try to determine if you are stressful from that data. So our research goal is to develop a way to determine continuously the stress levels of individuals with unobtrusive with low cost. So what this means is that uh, if we develop a way to determine stress continuously, then we can always spot the stress problems at early stage, and we can prevent things from happening. And also, if we do it unobtrusively, with that means that the like um, will be the clients will be paying no attention to the detection process, so that we can monitor individual's stress level really easy. Okay, so this is the recent technical advances. So in 2019, there's this paper called Continuous Stress Detection with Sensors. So this is the method I talked about, like using the watch. You can see from the image below. So basically, they collect data from these wearable devices, and then they like feed the data into a certain algorithm, and then the research group uses some classic machine learning algorithms such as support vector machine and KNN and so on and so forth. And also there's a CMU research that is stress detection for keystroke dynamics. This is the one research that we will be focused about in this research survey. Okay, so just a brief discussion about the trade-offs between these solutions. So if you're using the sensors, it means that you can collect stress related data accurately, and also determining stress level will be straightforward, as you can imagine. If you're doing it without sensors, it will be low cost and easy to use for the clients, but you have to think of an innovative way of doing data collection. Also, the whole process could be inaccurate if you do not have good data or algorithm. Okay, so I'll pass it to Varun, who will be explaining the CMU research to you guys.
Right. So first of all, let's just dive into what questions we're trying to answer. So in the paper, they talk about three major questions. One is, can we even identify stress by analyzing keystroke dynamics? Basically, what we're trying to see is, does stress impact people in a way such that there are changes in their behaviors which are apparent in their keystroke dynamics, how they type on a day-to-day basis. Are they pressing keys for longer? Are they taking more time between keys? What is the change that stress has caused there? From there, they try to see if there are universal classifiers or markers for stress. Are there certain things which occur in all people which indicate that a person is going through stress? And finally, can we cluster patients together based on their response to stress? So the general outline of the experiment was they looked to induce stress on subjects, and it was very important for them to verify with physiological measurements that the patient was indeed undergoing some stress, because their paper is trying to create a classification tool to help tell between patients who are undergoing stress and those who aren't. So it's very important to have a clear distinction between the two. So patients who were put under stress, they took physiological measurements to ensure that they were under stress, and they analyzed their typing for how long keys were pressed for and time between keys, both when they were in a neutral state and in their stressed out state. To bring patients to a neutral state, they did this through having them watch relaxing movies and performing a simple task. And to stress out patients, they timed them during multitasking exercises, and they gave them negative social judgment. After both of these, they did analyze they took physiological measurements to ensure that they were stressed out or they were in a neutral mental state. And what they found was actually really cool. They were able to train a classification model to identify when someone was stressed out and when someone was not stressed out based solely on their typing. And this was a huge development for them, because we can now look at just someone's typing patterns. And however, there were a few issues with the model. The model didn't really work well across subjects. So we were able to train the model with one individual's data, and we were able to tell when they were in a stressed out state versus a neutral state. However, since reactions to stress are so individualized, there were no clear pattern when the model was trained on the entire population, as opposed to just individuals. So they hypothesized that maybe there are clusters of people. Some people react to stress in a certain way, and we can identify groups of people that react to stress in the same way, and hopefully train a model for each of these individual groups to have a more accurate reading of when people are stressed out. And unfortunately, they found that there were no clusters found. People react to stress on a spectrum. Everyone is hyper individualized based on how they digest stress and how they interact with it. So unfortunately, they weren't able to create a model which works for a larger group of people. However, in the future, they're hoping that they can use these same algorithms and modify them slightly, modify the training data slightly, to help potentially detect other neurological diseases, Alzheimer's, Parkinson's, dementia, any sort of cognitive decline, carpal tunnel syndrome. And this would be a huge development in this field, because now we're able to continuously track someone's mental health, catch diseases early on, and provide them treatment much sooner than they otherwise would be able to get.
Okay, this is our last slide, so I guess that's it for our presentation.
Thank you.